Welcome to my channel. Today we discussed about the higher order differential equations part 1. Here you can see the definition of the higher order is an equation of the form d power n plus p1 into d power n minus 1 plus p2 into d power n minus 2 plus so on pn into y is equal to q of x, where p1, p2, p3, dash pn are constants. Q of x is a function of x, therefore it is called a linear equation of order n with constant coefficients of higher order. For this type of equations, solution is y is equal to complementary function plus particular integral. Simply it is CF plus PI. Today's topic is how to find the complementary function is the main objective of the today's class. Come to the given equation. First write the given equation into operator form. First write the given equation into operator form. What is meant by operator form? Transform the d by dx into capital D square by dx square into is equal to capital D square, d power 3 by dx power 3 is equal to capital D power 3 and so on is called the operator form of the given equation. Next, after writing the operator form, write the auxiliary equation for the given equation. How to write the auxiliary equation? Replace capital D by small m, that is f of m equal to 0 is called auxiliary equation. After writing the auxiliary equation, find the roots of the equation by any known method. I will explain later by taking the problem, that is roots. After finding the roots, if the roots are type 1, real and unequal. Real and unequal means if the roots are m1, m2, m3, so on, all are unequal. Then complementary function is c1 e to the power of m1x plus c2 e to the power of m2x plus c3 e to the power of m3x, so on. We can see the counter example. If the roots are 1, 2, two roots are there, therefore it is m1 and it is m2. What is m1? 1. What is m2? 2. Therefore c1 e to the power of x, m1 is x, 1 into x, plus c2 e to the power of 2x is the complementary function for 1, 2. Next, if the roots are 1, minus 1, 3, three roots are there. m1 is 1, m2 is minus 1, m3 is 3. Therefore, complementary function for three roots c1 e power x, c2 e power minus x plus c3 e to the power of 3x is the complementary function for three roots. Similarly, you can take four roots 1, 2, 3, 1 by 2. Four roots are there. You can read it as m1, m2, m3, m4. Complementary function equal to c1 e power x, c2 e power 2x, c3 e to the power of 3x plus c4 e to the power of 1 by 2 into x is the complementary function for four roots. This is the counter example for the real and unequal. Come to the, if the roots are real and unequal, second case 2, real and equal. Real and equal means all the roots are m, so on. Therefore, complementary equal to c1 plus c2x plus c3x square plus so on e to the power of mx, where m is equal root. Counter example is you can take the roots are 1, 1. Therefore, complementary function equal to c1 plus c2x into e to the power of x is the complementary function, because m is 1, m is 1, both are equal. Therefore, here you can write m value. Next, 2, 2 are the roots of the equation. Three roots are equal. Therefore, c1 plus c2x plus c3x square into e to the power of 2x is the complementary function for 3 roots, that is m comma 3 m's are there, 3 roots are there. You can write C3 constant c1 c2 c3. You can increase the x terms. Next you can take the another example 1 by 2 comma 1 by 2 comma 1 by 2 comma 1 by 2. 4 roots are there, therefore all m's are equal, but 4 roots are there, 4 roots are there, therefore you can write up to c4. Therefore complementary function equal to c1 plus c2x plus c3x square plus c4x power 3 into e to the power of 1 by 2 into x, where m is 1 by 2, where m is 1 by 2. This is the complementary function for 4 equal roots. Coming to the complex, it is the complex form is a plus or minus ib. When you get the complex form, inside the value is minus 1, root minus 1 is equal to plus or minus I, root minus 4 is equal to plus or minus 2i, 4 root is 2, root minus 1 is plus or minus 1, that is plus or minus 2i, root minus 7 is plus or minus I root 7, root minus a square is plus or minus ai. Like this we get the complex form. Therefore complex form complementary function equal to e to the power of ax real value c1 cos bx plus or minus c2 sin bx. Example is 2 plus or minus 3i, then the complementary function equal to e to the power of 2x into c1 cos 3x plus or minus c2 sin 3x, because where a is equal to real value is 2, b is equal to complex imaginary value is 3, therefore this is the complementary function. If you get plus or minus 2i is the complex form, there is no real value, the real value is 0, then complementary function is equal to e to the power of 0x into c1 cos 2x plus or minus c2 sin 2x is the complex form. E power 0x is 1, therefore simply it is c1 cos 2x plus or minus c2 sin 2x. Coming to the last, if the roots are sorts means alpha plus or minus root beta, then complementary function equal to e to the power of alpha x into c1 cos h root beta x plus or minus c2 sin h root beta x. What is the example for sorts? 2 plus or minus root 7, then complementary function equal to e to the power of 2x into c1 cos h root 7x plus or minus c2 sin h root 7x is the complementary function for the sort. It is the example for the sorts. Here you can see 1 comma 2 comma 3 comma 3. Next example, 2 roots are unequal, 2 roots are equal, combination of real and unequal and real and equal. For this type of example, this type of roots, the complementary function equal to, for unequal, c1 e power x, c2 e power 2x, c3 plus c4x into e to the power of 3x is the complementary function, because it is m1 and it is m2. These two roots are m comma m. These two roots are m comma. These two roots are equal. These two roots are unequal. Unequal means this type. Equal means second type. Next come to the two roots are equal. Here you can see first two roots are equal. Second two roots are equal. Therefore complementary function equal to c1 plus c2x into e power minus x plus c3 plus c4x into e to the power of 2x. Here first two roots are equal c1 c2, second two roots are equal c3 and c4. This is the complementary function for two roots are equal. Next here you can see the two roots are complex but repeated. What is the complex form? A plus or minus ib, there is no real value, therefore c1 plus c2x into cos 2x, c1 plus for repeated. Similarly c3 plus c4x into sin 2x is the complementary function for two repeated complex numbers. Next, here you can see one is unequal, second one is complex. One is unequal, second one is complex. Therefore, complementary function equal to e to the power of 3x, e to the power of 3x m1. Here you can see a plus or minus ib. Like this you have to remember, it is m1 and it is a plus or minus ib. C1 into e to the power of 3x is over, plus e to the power of x, e to the power of ax, c2 next constant cos x plus or minus c3 sin x, c3 sin x is the complementary function for unequal and complex. Next, come to the one complex, one odd. You can write the complementary function equal to, what is the complex form? E to the power of ax into c1 cos bx plus or minus c2 sin bx is the complex form. Next, odd form is e to the power of 2x into c3 next constant c3 cos h root 3x plus or minus c4 sin h root 3x is the short form. Okay, bye.